Welcome back to the Python Praxis. In Lesson 6, we have explored lists, how they work, how to modify them, and how they give us flexibility to manage collections of data. Today, we will step into a new kind of collection in Python, tuples. At first glance, they might look like lists, but they carry a very special property. And once you understand it, you'll see why tuples are extremely valuable in programming. So, let's dive in. What is a tuple? A tuple is simply an ordered collection of values that are read-only. The key characteristics of tuples are: tuples are immutable, meaning that their values cannot be changed after creation, and the order of data in tuples matters. Tuples are similar to lists, but lists are mutable, while tuples are immutable. This is the key difference of tuples from lists. And that immutability is powerful, because sometimes we want data to stay untouched and safe and not be accidentally modified. A tuple is defined using parentheses. Each item in the tuple is called an element. How do we create a tuple? Very simple. The syntax is a tuple name in the left side of the assignment operator, and the elements of the tuple on the right side, enclosed in parentheses and separated with commas from one another. In the example below, we name the tuple as my tuple, and we put 3 elements in it, numbers 2, 4, and 6. That's it, we've just defined a tuple with 3 numbers. The question now is when to use tuples. When should we use tuples instead of lists? We use a tuple when we know that the values will not change, or when the data represent a fixed structure. What can we store in tuples? Tuples can contain various data types like integers, real numbers as floats, strings, and booleans. Tuples can also contain other tuples, lists, or any Python object. In tuples with only one element, the comma is required. Let's see some real-world examples where we use tuples in programming. A geographic location with latitude and longitude. A person's profile with fixed details like name, age, if he has license, and ID. For instance, we define a tuple named person equals to, and inside parentheses we put Jordan, 33, true, 1.82. To print the contents of a tuple, we use the print command, putting the tuple name as an argument. We can also check their types with function type, and yes, Python will confirm they're all tuples. To start working with tuples, let's see how do tuples behave. They keep order. This means 1, 2 is not the same as 2, 1. You can index and slice tuples just like lists. You can loop through tuples. You can use tuples in conditions. But here's the difference from lists. Tuples don't have methods like append or pop, because tuples are immutable. They only support 2 methods, count and index. Here we have some examples with tuples. In example 1, we have a tuple called my tuple that contains in order 5 numbers, 2, 4, 6, 8, and 10. If we print my tuple and inside square brackets we put number 1, Python will print only the second element, number 4. If we print my tuple and inside square brackets we put 1:3, Python will print numbers 4 and 6. In example 2 we have, for item in my tuple, print item. Here the for loop will print every item in my tuple. In example 3 we have a conditional, if 6 in my tuple, print found. This code checks whether number 6 exists in my tuple, and if this is true, prints the message, found. Let's see tuples in action with an exercise. Tuple creation with prime numbers. We want to create a Python program that does the following. Finds all prime numbers between 50 and 150. Calculates the square of each one of these prime numbers, stores those squares in a tuple, and prints the final tuple. We begin by creating an empty list called prime squares. This list will later store the squares of all the prime numbers we find. Then we start a for loop. This loop goes through every number from 50 inclusive all the way up to 150 exclusive. Each of these numbers will be checked to see if it's prime. In the next 2 lines we set up a condition. If the number is at least 2, we assume at the start that it's prime. We do that by assigning to Boolean variable isPrime the value true. We'll test this assumption in the next step. Next up we create an inner loop. This inner loop checks all possible divisors of the number. starting from 2 up to the square root of the number plus 1. Why the square root? Because if a number has a factor larger than its square root, the matching smaller factor would have already been checked. This makes our prime check more efficient. Inside this inner loop, we check divisibility. If our number divides evenly by any of the numbers in this inner loop, it means it is not prime. So we set the Boolean variable isPrime to false and immediately break out of the loop. After checking all possible divisors, if isPrime is still true, then our number is confirmed to be a prime. We then take its square using num**2 and append that result to our list prime squares. Once the loop is finished, we convert our list into a tuple, which we call result tuple. Remember, tuples are like lists, but they are immutable, meaning their values cannot be changed. Finally, we print the message: squares of prime numbers between 50 and 150, and then we display the actual tuple of prime squares. So, the output will be all the squares of prime numbers between 50 and 150 neatly packed into a tuple. Tuples are sequences. Like strings, lists, and ranges, tuples are part of Python's sequence types. That means they support a lot of built-in functions or operations. Let's see an example. We create a tuple named numbers containing 13 integers. Some of these integers exist multiple times inside this tuple. So we can easily get length, min and max, sum, count occurrences, find the index of an element, even sort the tuple into a list. Tuples are much more powerful than they first appear. Now let's take a closer look at the functions, methods, and operations we can use with tuples in Python. Tuples may be immutable, but we still have plenty of useful tools to work with them. First, we have the len function. This simply returns the total number of elements inside the tuple. Next, the max and min functions. These return the largest and smallest element in the tuple, respectively. Of course, this works when the tuple elements are comparable, like numbers or strings. Then, the index method. This finds the position of the first occurrence of a given item, and you can even limit the search between positions S and F. Closely related is the count method. This tells us how many times a particular item appears in the tuple. We also have the membership operators in and not in. These are handy when you want to check if a value is present or absent in your tuple. Next is tuple concatenation, tuple 1 plus tuple 2. This joins two tuples together into a brand new one. Remember, since tuples are immutable, the original ones remain unchanged. We can also multiply a tuple. This repeats the tuple contents n times. And finally, we have indexing and slicing. Here we can access a single element by its index, a slice of elements between two indices, or even a slice with a step value, allowing us to skip elements as we go. So even though tuples can't be modified like lists, you can still analyze them, search through them, combine them, and access their elements in powerful ways. Here is another hands-on tuple creation exercise that includes process of numbers. We want to create a program that reads 8 integers between 5 and 15 from the user, stores the numbers in a list, converts that list into a tuple, creates a second tuple that contains the squares of the numbers, creates a third tuple that contains the squares of the numbers, but sorted in descending order. Alright, let's walk step by step through this program together. It combines user input, lists, tuples, and sorting. By the end, you'll see how numbers can be transformed and stored in different data structures. In the first 2 lines, we begin by creating 2 empty lists. One list, called values, will store the integers that the user enters. The second list, called square values, will store the squares of those integers. Then, we start a while loop. It will keep running until the values list contains 8 numbers. So the user must give us exactly 8 valid numbers before the loop stops. Inside the loop, we ask the user for an integer between 5 and 15. The input is converted from text into an integer using int function. Next is an if condition that checks if the number is inside the valid range. If the number is between 5 and 15 inclusive, the program accepts it. When the number is valid, 2 things happen. First, it is added to the values list. Second, its square is calculated and stored in the square values list. If the number is not valid, the program displays a friendly message asking the user to try again. In this case, nothing gets added to the lists. After the loop is finished, meaning we have collected 8 valid numbers, the lists are converted into tuples. Why tuples? Because tuples are immutable, which makes them a good way to store final results that we don't want to accidentally change. Next, we take the list of square values and sort them in descending order, thanks to the option reverse equals to true. Then, we wrap the result using the tuple constructor to create a new tuple called sorted squares. Finally, the program prints 3 results: the original tuple of numbers entered by the user, the tuple of their squares, and the tuple of these squares, sorted from largest to smallest. So this exercise nicely ties together input validation, loops, lists, tuples, and sorting. It shows how data can flow from user input to processing and finally to structured immutable results. So, what have we learned here? Tuples are like the unchanging cousins of lists. They're ordered, they're immutable, and they shine when you want data that shouldn't be altered. You saw how to define them, how to use them, what functions and methods they support, and even how to combine them with user input and loops to create real programs. In the next lessons, we'll keep building on these concepts and see other powerful structures in Python. So, keep practicing and remember, sometimes safety and immutability are just as important as flexibility.